All right, this week we're gonna play around with this LCD screen. It's a pretty cool little component. It uses something we haven't messed with before yet. We talked about it in class, but it's called I2C, and it allows for lots of devices to be hooked up to a single bus because then you can access them with um, a specific address, and that allows you to communicate with multiple ones. So we're going to go through this one and set this up. It's fairly basic. You can look at the schematic online. Most of this is actually for the 7-segment display, so don't worry about it too much. But we have the leads coming out of the device, and I grabbed the set of cables. For this one, you're going to want to use the female to male connectors. So you're going to use this strip that's got female plugs at one end, male plugs at the other, and you're going to just tear off 4 of them, keep them in a bundle. That's what I did with this, and it makes it a lot easier to keep it wired up. So I grabbed the black, white, gray, and purple leads, and then just tear that off as one big hunk of 4 wires. Then you're going to plug the ground one. Black is ground. By the way, the board on the back is labeled. It's kind of hard to see it, but you've got ground VCC, which is going to need to be 5 volts, not 3.3. So that's why we have it plugged into our 5-volt lead right here, the first pin on this side. And then we've got SDA and SDC, and I'm sorry, SDA and SCL. And those we're going to plug into these 2 pins here. They're pins, let's look at the schematic. GPIO 6 and 7 is what we're going to use here. They are SDA and SCL. So we'll reference those here in just a little bit. All right. So here we can kind of see it. The lighting in here isn't all that great. And I think if I kind of get it blown up, so you can see here, it's just counting numbers right now. All right, so to do this, you're going to need that LCD library that I've got in the documentation. Again, you're going to just grab that though from GitHub. It's this GitHub D Halbert CircuitPython LCD. And you're going to go to that site. You're going to go to code, say download zip, and it's going to download it as a zip file, like you can see there. And then you're going to open that up. Windows has a kind of a normal way to do it. It'll look like this, and then you'll go into the CircuitPython LCD main, and then grab that LCD. You'll just say copy, and then you'll go to your CircuitPy device and go into the lib folder and just paste it right in there. Don't worry about these Adafruit ones. That's some other stuff I was working on. Okay, so that's how you get the library. You get the links in the course, the homework sheet. And once you do that, you can grab the sample code. Here we've got some different import statements. We have some statements here about importing the LCD module and the interface. You can look at some of this code if you want to. The LCD code is actually, it's pretty extensive. And then there's an interface, which is kind of like a file specific to this screen, and not even so much the screen. It's really for this backpack control back here. That's what they call it, as an LCD backpack. And yeah, so you can look through that interface and that LCD code if you want to. We're not going to go into it too much. The main thing is, again, I2C, the main communication mechanism for this is to use a byte array to send data to and from it. This library kind of hides all of that, so we don't have to worry about that too much. The main code here is we're going to import board, bus IO, and time. We're going to, from the LCD library, we're going to import that LCD object and the interface. And then we're going to create the I2C. So this is just CircuitPython. We're going to use busio.i2c, and we're going to say the SCL board is board pin GP7, and the SDA is pin 6. They need to be that order. And if you look on the schematic card, pin 7 is the SCL, pin 6 is the SDA. Then we try for a lock on the I2C bus, and then we scan it, and we report out the first address we find. In this case, it's the screen. If we had multiple I2C devices connected, then this scan would give us a list of those different addresses, and we'd have to figure out which one's which. Then we unlock it so that we can access the I2C bus after that. And then we define what our LCD is. It's this. We're going to use this interface. We're going to send it the I2C object we created and the address that we calculated from the scan. And then we're going to say, okay, it's got 2 rows and 16 columns. So we do have to define how big the screen is. And then we can clear it. So that's a function that's on this LCD object is clear. And we'll look at some of the other ones here. And then we've got our while true loop is going to loop through continuously. We're going to create a variable called count and start it at 0. And then we're just going to start incrementing it. We'll play around with some of this home stuff here first, or in a second. But right now with this, you can see here that we just have this kind of continuous counter, and we can slow it down by changing the time that we wait. That'll reset it. And so now we have our clock counting up. All right, so some of the different functions that we can use here. LCD does have this home function. If we take this out temporarily and save it, what's going to happen here is you see there it's tacking on the number to the end of the string. The screen has a cursor, a place where the code, you can see it's started over again, and it's coming back on the first line and the second line. So this cursor of like where it is on the screen is constantly moving every time we write something to it. Now, if you want to, you can have it write something and then go back to home with the cursor so that when you write something again, it'll overwrite it. So that's what we were doing here. If we uncomment that code and save that again, by putting in this home, now it prints it. It prints out the current count, but then we go back to home before we print out another one. And so that's why it's overwriting it each time. Another thing is the LCD clear. Now clear is kind of like home. We can actually just use kind of one or the other here right now. And it's going to look a lot the same. But clear gets us some more capabilities later. So clear, sometimes you do want to completely clear the screen, because when we write something to each one of the characters on this screen, the screen doesn't care that we just wrote something to it. If we write something else that's shorter, the rest of it will appear. So let's actually kind of play around with that. We're going to create a message, and we will just say hello world, and we'll say lcd.print message. And we're not going to do the clear, but we will do the home. Okay. And actually, let's move this outside of here. Okay. So we're going to, we clear it outside of the loop. We're going to create a message and say hello world, and then we're going to start our loop. So let's see what this does. All right. So this says hello world, but then it's overriding the first 2 characters with our number. And that makes sense because all we're doing is resetting where the cursor is going back to the beginning. That's all home does is go back to the beginning of the first line. It doesn't do anything with whatever's on the rest of the screen. And so if we wanted to, we could do We could do clear up here. So we could do time.sleep 2. So we'll wait for 2 seconds and then we'll say lcd.clear. And if I save that, says hello world, waits a couple of seconds, clears it, and then starts the numbers. So that's what clear does. Clear, it kind of what it sounds like. It clears out that whole screen and puts the cursor back at the beginning. Another way to kind of look through this is if we wanted to print multiple strings. So let's say we'll stop doing this. So we'll leave the clear in there. Oh, no, wait, we saw the clear. Okay, so now we'll stop worrying about the count. That was just kind of an easy way to get something to print. So let's do lcd.print hello. And we'll say time.sleep to lcd.print world. Time.sleep 2. Okay. And then we will, so we want to go to home there, and we want to go to home there again. And we'll not worry about that state. So now what it's going to do is it's going to say, hello, world. And then it says hello again. You'll notice we still have the 3 exclamation marks at the end there, because the screen is not being told to clear out the rest of the characters. So now it's just going to, looks like it's bouncing back and forth between hello exclamation marks and world exclamation marks. But the hello doesn't overwrite the exclamation mark. So one way we could kind of sort of fix this is we could say explicitly write out spaces. So it looks about the same. You see hello, world, and now hello clears out those remaining 3 exclamation marks, and we don't see them anymore. But that's not really the best way to do that, because you don't want to always have to remember how many characters you're dealing with. So the better way is to use the clear function. And so now, hello, world, and hello, no longer exclamation marks, but we're being very generic here. We don't know how long the strings are that we're going to pass to it. We don't care. We just want it to clear in between each word. So now you'll notice we actually have some repeating code here. And maybe we want to start talking about functions. And so we're actually going to pull this code out and put it into a function. So to do that, we'll say def. That's how you define that we're about to create a function. And we're going to say write string, or write str. And the string we're going to send it, we're going to say this is val for value. And then you have to put a colon at the end. And then you'll see that it indents the code on the next line because we are in a function. So now I just copied and pasted one of those. But we don't want to write hello every time. We actually want to write our value variable that we're going to pass into it. So I'm going to copy that and overwrite that. So now our function is very generic. We don't really know what it's going to write. It's just going to write whatever we send to it. And so now we can get rid of these, and we can say write str and str. Because our sleep is included in our function, we don't need those, so it makes our while loop nice and clean. And if we save that, it's going to look, I can get the lighting to play nicely, it's going to look about the same. Hello, world. But our code's a lot cleaner. It's a lot easier for us to debug it. If we wanted to, and we played around with this, there is a set position. So we can say lcd.set cursor position, and we'll say 0, comma, so we're going to be on the 0 row, and we're going to go in 5 characters. So now when we save this, now it shifted that over. And we played around with in class that, well, what if we wanted to center it? So then let's actually, instead of hard coding the 5 here, let's figure out how many characters over we really want it to be. So we'll say position equals 16 is our maximum number of characters minus the length of our value. So the string that we pass in is going to have a certain length, and we'll calculate that here. And we're going to then divide that by 2. Now, one of the things, if we pass this to this function and we save it, this is where having your serial connection and connected is helpful. Let's restart that. Okay, we get an error because it's saying, okay, we have an unsupported type. It's expecting an integer, but we gave it a float for our position, for our set cursor position function. So the issue here is we have calculated a float value for position, but we need it to be an integer. So a quick and dirty way to fix that is we can just wrap that all in an int function, which will convert it now into an integer, and it'll drop off the decimal point. And so now you can see hello is shifted over one more than the world is, and so it'll just kind of center it as best as it can. And so now if we add it in to to the world. All right, and we save that. Now it says hello to the world, and it's you can tell it's centered there because it's shifted over much more to the left. Now what happens though if we get outside of our 16 characters? So if we highlight all this, this says down here our selected number of characters is 14. So let's do big old world. So now we've got 22. So that's definitely more than 16. So if we save this, it's going to write hello, but then it kind of errored out. And it said column should be in the range of 0 to 15. So the reason for that is if we think about it, we passed it a string that's 22 characters long. So 16 minus 22, this part of the function, gives us a negative number. And that's bad. We don't want this to be a negative number. We want it to be between 0 and 16. And so here we can use a function that we kind of always get for free in Python. And it's max. So we give it a list of values, and it's going to give us the maximum of all of those. So here we can say we want the maximum of 0 and the current position value. So here, this value will come into here. This function will calculate a new value, potentially. If the position is negative, it'll calculate a 0, and it'll return that into position so that we can then use it later. So if we save this, now we get, okay, hello to the big old world, and it wraps over to the next line. It's really hard to see that on there. Come on, you. Hello to the big old world, and it wraps down. Well, we don't get a negative number, so that's what we want. Now, another thing we could do is we could make our list be dynamic. So we can say vals equals, and we want to make an array because we want our values to always be in the same order. And so we can grab our strings here and paste them up here. So then we can say for val in vals. That's how we can loop through an array, and our val variable will be each one of the values in the array. And we'll say write string val. And so here we could even say, let's make it 3 strings. So we'll save that. And just bump the camera. And so now we get hello to the big old world. Okay. So there we go. That's how you can pretty easily say, okay, let's take an array of values and print them to the screen. And that's kind of how it is. There are lots of other features of the LCD function, We can do LCD dot, and you'll get this list of helper functions if you go into the VS Code folder and edit your settings.json. And let me move that down here. And if you go in and put a comma at the end of the very last line, these were the 3 lines that were currently in my settings.json. I added a comma to the end here and then put in d://lib. If it's a Mac, I'm actually not quite sure what it's going to need to be to get to the lib folder. Yeah, but once you do that, and I think I've even had to restart Visual Studio Code after adding in the library. It doesn't immediately pick that up, but once I've restarted, I can say LCD dot, and then we can change apparently the character height. We can clear it, change the cursor position, change the home, or go to the home position. Print is what we're using to write the value. And you can do things like set the backlight. So here we could do set backlight equals false, I believe. Or does that want to function? Yeah. You want to do it that way. So if you do that, and now you still can't read it too well, even though it's not as bright. It's a little better maybe. Hello to the big old world. So maybe that's a little bit easier to see without that backlight on. For me in person, I can barely see that. It shows up better on the webcam than with the backlight on. So you can turn the backlight on and off. LCD dot set the cursor mode. You can which blinks it or not. Set the current position. Enable the display or not. Yeah, I'm not sure what shift display. Oh, I think that could help it like scroll something through it. That could be kind of fun. All right. And then a bunch of private functions that we won't mess with. So that's how to use the LCD screen. So please play around with it. Try creating a function like this and looping through an array if you can do that. But the setup should be fairly basic, and when you just pretty much set it up once, then you should be able to use it from that then on. All right, thanks.